So what I'm gonna do today is I'll do a quick run through the high level details about what Surreal-ORM is, which is not the final name, I don't probably, and then I'll show a few examples and maybe do a little bit of demo. Then we can do sort of like a Q&A. So Surreal-ORM is a Rust database. And the whole idea is to make you very productive and also catch it, focuses on catching your bugs as soon as possible. So compile time. So the main philosophy is if anything can be caught at compile time, it should be. And you can find a link at this URL. So what is the main problem? So what I noticed when I started this project was I tried about 10 different database libraries in Rust across different database engines, Postgres or even other graph database. So I was open to pretty much a wide range of database libraries, relational or graph. And across other languages from Java to Ruby to Go, Elixir, I've tried a bunch of ORMs and I noticed that I had these main issues. They either felt too underpowered or overly complex to use, so not very user-friendly. And I wanted a middle ground that could still give me my cake and make sure I have my cake. And that was what birthed this library. So I actually started with MongoDB. I did some little work about a weekend, and in December 2022, I believe, I said I was gonna add a bunch of ideas after I discussed with an author of a library on Discord about what's my like the ideas I have in my mind. And I think this thing should be possible, thinking from like first principles. And initially, I was actually trying to contribute to some libraries, but I realized that we had fundamental philosophical differences in terms of how they should work and what the API should look like. So I started to create this. So I wanted to create something that would be very easy to use. Once you get the angle of the general idea in less than 5 minutes, it should be easy to use, instant productivity, and it should catch issues when you're working as soon as possible. So strong type safety and be very expressive. So why did I start with a graph database? Currently, I support SurrealDB, which is a graph database written in Rust, and there are many reasons for this. I have no affiliation with SurrealDB. This project is still a solo project and 100% funded by me and my time. But I started with SurrealDB because first it's written in Rust, so I could access the underlying engine directly without having to do run some on the extra process or FFI into some C libraries and to enable some functionalities. But other than that, I think the main reason why I started with Graph is because I believe data inherently are graphical in nature. And what do I mean by this? When you're talking about data, you talk about different entities and relations and all that. And basically, we're talking about graphs. In relational database, you can think of tables. And when you have tables, you have different levels of normalization. And for example, when you have many-to-many relationship, you would typically create a bridge table. Think about a product and location table, then you can have like a product location, sort of like a bridge table to cross from this to break the many to many into one to many on either side. And you can think of that bridge table as an edge in a graph. That's the relation between the two tables. So my my flow of thought was if I can start with a graph, then it would be much easier to create abstraction that would map pretty much to other forms of or other paradigms of database. And that was one main reason why I started with a graph database, because I was still sort of experimenting and thinking through the different trade-offs of different with every little details. So the key problems I encountered with the existing tools were the limited capabilities. So I tried some libraries. I tried to do some like make some mistakes, obvious mistakes, and I would expect to get like instant feedback or at the very least some kind of like runtime check, and it they wouldn't do that. So I would be pretty like surprised, even though they were using macros in some occasion. And I felt like I I like to build my tools in the sense that I don't have to rely on the developer doing things right. The tools just make the developer or the user nudge them in the right direction, sort of. And also the syntax would be unintuitive. So the general idea I have, like when I'm designing this API, I want them to map almost one-to-one to how the raw queries would read, even when they are abstracted into some kind of generic function. When you're writing your queries, either you even if you're using the query builder functionalities, it should map directly. You should be able to map mentally to the raw queries. So there are little nuances that I tend to pay attention to, things like how they read. If the raw query is reading from left to right, then the query builder or whatever other abstraction should also read from left to right. And I believe that every tiny barrier to mapping that increases friction and frustration, and why people tend to complain about ORMs and stuff like that. So, for example, if you use different libraries, like Alchemy in Python, and even a bunch of other libraries in Rust also, you would notice when people write the condition, and I'll show some examples later. Let's say you want to have like age greater than 99 and something else. When some libraries create the abstraction, they might use an OR function and sort of put the condition between it. So you're flipping now you're flipping the flow of the stuff and little things like that. I wanted to make sure I avoided that, and you see that. Then also friction. So I wanted something that I could just work with without having to go through setting up Docker. And I know that currently SQLX, for example, support, which is it's more like a query compile time query checker, and it does the automatic type inference also. If you want to get the compile time checking, you need to either have a live database connection, or you would have to cache some stuff locally. But these are extra stuff that you need to work with. And besides that, it also doesn't do anything for you automatically, at least as far as I'm concerned. This might be the first library that does your schema migration automatically for you. And I think even though you might want to have some extra stuff, most of the things you actually need to do, in my opinion, are quite predictable. You're mostly adding some fields, removing and changing their definition for the most part. And these are fully supported in Surreal-ORM. So currently we support both one way or unidirectional or two-way migration. So you want to have like reversible bidirectional migration. And I'm going to show you a little bit of demo. And besides that, also, some of them are fragmented. So for example, in SariDB, there is a um, migration tooling, there's some query building tooling and all that. and I wanted something that would put them all in the place and make the API also consistent. And in a nutshell, when you're talking about they are either overly complex or too simplistic. I wanted something that could make you very productive. Like you start with it, you get the idea, for probably 80 to 90 or more of the use cases, they are just like intuitive for you. And lastly, I thought a lot more could be validated at compile time if you can provide the necessary metadata for different tables or different structs. We can validate far more, in my experience, at compile time. And the little stuff we should also be the things that we can validate at compile time. We should be able to automatically generate some kind of runtime error for that. Um, so I have things like for Surreal-ORM, we've got like statically checked raw queries, which I will be showing in a bit. And currently the support checking your queries and also the interpolated variables, basically the parameters. And also, I believe the APIs are intuitive enough. And there is a concept that I've introduced called Query Turbo, which I'll be demoing. Essentially, it allows you to write something that seems like pure Rust, but without having, especially when you're working with complex queries or blocks, which I will be showing, or transaction, without in other libraries, you typically have to pass DB connection and do some stuff at runtime and pass the DB connection between the queries. But this does all those things automatically, and it supports even if else, for a loop, and it could also be nested to as deep level as possible. And the types are also automatically inferred for a a large section of types. So if you're declaring your struct, it will automatically infer the database type, which I'll be showing in a bit. And when it cannot infer the type, it's going to prompt you that you should actually provide the type explicitly. But more importantly, even when you provide a type on the field, it cross-checks that with the field type and see if they are actually compatible. So it doesn't just leave you um, to just put any type. So if you say this is a string and it's not able to infer that, it should be able to infer just the basic string or clone and write string. Um, if it's not able to infer that and you put explicitly that this is supposed to be an integer or a date time, you still get the compile time error that an integer is not compatible with a string. And also I have a concept of type safe ID. So basically IDs are specific to their own struct. And for you to create a new ID for a specific struct, some method are generated automatically for you to create different kind of IDs, either simple ULID or UUIDs or even more complex IDs. So if you're trying to use a ID of a user struct on a table on, let's say, a book struct, it's gonna be incompatible. And like I mentioned earlier, there's automatic schema migration, and um, we have a concept of statically type checkers also, which I'll be showing in a bit. So what type checkers allows you to do is when you want to set, mostly in your update queries or merge queries, if a field is, let's say, age and it's unsigned integer 8, if you try to put a string or even an unsigned integer 64, you're gonna get a compile time error. And yeah, we've got some other ORM features like statically checked field I mentioned. And also we have a concept of deep type graph traversal, which I'll be demoing also in a bit. And basically what that is, in SurrealDB, if you have a user struct, and for example, it's links to a foreign table called, let's say, book, you can basically traverse that from user to book. And let's say book links to some other table through an edge, you can basically traverse the entire stuff limitlessly. And in addition to that, you can put in some conditions in between the traversal. Let's say you just want to select the first book, or you want to have books where the title starts with stuff and a bunch of stuff like that. We also have the concept of loaders. So loaders are mainly for if you want to load whether or not you want to load the foreign tables. So if you want to load, let's say the one-to-one relationships or one-to-many and also the parameter the when you're writing your queries, the parameterizations are automatically done for you. Yeah, so that's mostly it. And the future, I plan to support Postgres and other relational databases, MongoDB and Cassandra, and open to supporting others. That's mostly it for the first part. I could do a quick show through this. So for example, I think I'm just gonna do a demo actually. I If you have any question, please let me know. Does anyone have any question?
I think we only see the slides though. I feel like you have something else to work.
Oh, okay. I thought I was sharing my entire window. Let me try to. Uh, Thanks for the heads up.
Yeah, man.
I
No worries. Yeah,
awesome.
we see it
All
now.
right, perfect. So, first, I can start with, let's say, the raw query, for example. And so, if you mistype a query, the idea is that you should get an instant feedback that something is wrong. And
Can I
this,
interrupt for a second?
pardon?
Can you make the size a little bit bigger? Yeah.
Is it better now?
Is that any better here? Or maybe a little bit larger?
I can do that.
Okay. We're good.
Oh, okay, perfect. So, in this situation, for example, if we mistype something, we're gonna get an error. And as you can see, yeah, so it also supports variable interpolation, and you can sort of use this object syntax, not like JSON. So if you mistype something here, it's gonna catch it, and let's say you miss that. We have this name variable. If you miss that, you get that. You miss that instantly, you get a feedback. And in addition to that, you can have multiple queries, and it also supports the interpolation across them. If you miss one of these variables, you sort of get instant feedback on something missing. And you can have even much more complex queries, which Surreal-DB supports. So these are for like the raw queries. And currently I'm working on a feature which is sort of like the last feature that came to my mind too. That would be that would automatically infer the return type of all these. And for those that cannot infer, you can provide the types explicitly or even provide an override. And that is the last feature I'm working on before the release. So I was talking about the query intuition or intuitiveness. And this is an example of what I was referring to. So this is a select statement. And if I open my screen to this is supposed to be the raw query. Like this is the raw on this side. Yeah, this. And this is the query builder. So this supports query builder, ORM functionality, and something called query turbo. So as you can see, when you're reading the query builder function, you see this reads select all from weapon, where strength inside. We have a subquery, select value strength from this, order by. You notice that when you're reading when you're reading the, let's scroll down a little bit. When you're reading this, it almost reads exactly as the query builder would read, right? And it maps almost one-to-one. And you can sort of think about, you can sort of visualize what the raw query would look like just looking at this. And you also notice that it knows automatically that this is a subquery, and it knows to wrap that in a bracket and things like that. And you can even have a lot more complex select query and others. But this is more a simpler version of that. And another I was talking about is Query Turbo, which I can show an example. So if you're having a transaction, for example, you can use this transaction macro, and you can just sort of write a bunch of queries. You have to start with a begin transaction, right? And you also have to end it with a commit or cancel transaction. And when you look at this, it supports having a statement. So you can assign an expression to the variable, and you can also have a standalone expression also. So yeah, what we're doing, for example, is we are creating this balance. We're creating two accounts. And what you're going to notice is that this supports having a variable from outside of this, right? You have this amount to transfer, which is 300 being being used here. And you also notice that when we're creating the ID, so if we go to the definition of balance, you see that this actually is a table which has an ID, a more generic ID, where it takes both the table name balance, that's what we're using self, should be able to do balance also. But to make it more easier to work with, you can just do self, and then you're saying it should be of type string. So when you want to instantiate that, what you're gonna do is you're gonna use this create ID method, which is automatically generated for you. And then we also create two accounts. And you notice we are inlining the variable here, which is this first and this here. Then these IDs are also coming from outside. It's able to do that. We can also move that inside of this. Then we're updating these two accounts. So there are two ways you can do it, or many ways actually, just these are one of the two ways. So here we're decrementing this balance by this amount, right? So this amount is 300. You notice that when we try to put a string, we actually get an instant feedback because that is not an F64, right? So you get an instant feedback because balance expects we automatically generate some kind of like schema for the entire graph. And it knows that balance is F64. So you put a string here, you're going to get an error. You try to put a string or something else, it's not going to work. You have to put in an F64 and it's going to work. If you do this, that would be valid. And this would also be valid. But you also notice that what we can do here is we have this balance from this initial declaration, right? And this returns basically what we've generated here. So what if we want to access this field? Basically, what this query is going to return at runtime. We want to access that, and we want to increment. We want to use that later in the one of the queries. So you can see in this increment by, we can use this method, which is also automatically generated for you, called with path. What with path essentially does is it helps you traverse the graph from the origin table. So what you're going to do is you're going to specify the table you want to start from. In this case, we want to start from the balance table and express this. E means empty. Actually, it's an alias. You see it's empty, so you can write this in full and import that. It's an alias for empty. What it does essentially, if I reduce this a little bit, is it helps you traverse the entire graph. So we want to traverse the field amount here. And you notice that when we use this with path, we say we want amount, right? We're able to assign that to this, and that actually works. And you remember that this checks, if you try to put in a string, it's not going to work. Even if it's a number, it's not going to work, right? But it knows that when you're traversing this, this is like a field from another or an earlier declaration. You can also assign a parameter from within. Let's say you say a new amount, and let's say this is that, and if we go here and we put new amount, this would also work, right? So it's smart enough to allow you to use variables from within and from outside, and also do this traversal. And you can, with this, you can write very complex query. And an example I could show with, and also, so here basically we run that. If I remove this, let's see what this returns. So we, let's just, you notice that this actually returns transaction completion. And if you do, let's say, cancel, you do a cancel here, this returns, it's also a transaction completion, but it has to be one of those. So if you do something else, like this has to be commit or cancel transaction, and this has to be a begin transaction. So we're just directly running that. And you see that this actually works as it should. If we run this test, maybe I'm gonna run this right now, actually. Okay, I can walk through this, what this is doing. So this passes just to show that this actually works. So what we're doing is we're running the transaction and we're running this select query. For example, this is also another stuff. A range query you can do from ID, and it supports all inclusive and exclusive. So you can do from ID 1 and 2, and this does everything automatically for you, the binding and stuff. You can also do, so you can do ID1 excluding the upper, or you can do up till that including the upper bound. I believe you should also be able to do this. So basically you're saying from ID1 upper, and you can do on the other, you can do this also. So all these range queries are also supported. So what this does essentially is we have this balance with initial amount of 300, and we're creating these two accounts with this. So if I open this maybe to the right side, you notice that we are incrementing this by the amount. From this part, we should be 300, and we're doing the same to the second account, which is ID2. We are incrementing by, I believe, 300 also. If we go down here, you see that we have two accounts when we select, and then let me try to close this now. We have the balance for the first one being this. If we add 300 to this, it should be 135,905. And you see this is 135,905. And if we do the same to the second one, it should be 91331. And when you go down here, okay, I might be missing something here. Oh no, actually we're decrementing. So that was a mistake on my part. We're decrementing here. And you notice that if we subtract that 9, let's do 91031.31 minus 300, we get 9731.31, which is what we're getting here. So it does everything for you automatically. And within this transaction, you can have an if statement. Also, you can do like if I don't know, if true or if balance greater than, you can do something like great GT 400, and you can run some kind of query here. Let's see. And let's say you run a select. You can write a, I can actually show another example here, more complex example. We have it here. Is the query turbo. So this is an example of that. Let me zoom out a little bit. You can still see what I'm doing. So if we go to query turbo, which is, you can use the query turbo also for your transaction, right? But this allows you, the difference between that is that transaction macro enforces that you have begin and commit transaction. But when using query turbo, you don't have to do that. Yeah, we're doing similar stuff, but in addition to that, you see we have much more complex queries. So yeah, we're accessing the balance amount that we created earlier, and we have an if else statement with else if, and then we have a for loop, and we have an if else statement within that, and we have a nested for loop, and we have another creation within that. So you can have very complex queries. You can pretty much just keep on nesting. Here we have 3-level nesting of if statement, or even for. We have a for loop within that date level. So this allows you to write very, very complex queries without looking abstracted. And it does everything for you at compile time. It generates the right query. It makes sure everything is parameterized properly and sanitized for you. And I wanted to show uh, some other little stuff. I can, let's see, I have the if statement, if else. So that's the implementation. I wanted to show writing some if statements. Okay, so these are a bunch of other stuff. So some little stuff that I try to pay attention. If you want to have a standalone if statement, you can use a query turbo here also. But yeah, we're having an update statement, and within this set, you notice that for name we're using this if statement, and name should be a string, right? If we go there, it's for weapon, name is going to be a string. And here we're also able to assign an if else statement, but if we try to put a number here, we should get an error. As you can see, we get an error instantly, but we're able to have an if else statement there. So it's able to understand all those things. And yeah, you can have less than or equal to, or just do LT, depends on what you prefer. This is an alias to it, and it's well documented. So you can see the documentation here. But one of the nice things I try to also pay attention to is, for the most part, when choosing the right trade-off, making invalid state unrepresentable. So like a state machine. So if you're gonna have an if else statement, if you do if, you have to go to then before you can go to if else. After then, only then can you go to else if or else, or you can just end it straight away. You see that this you cannot go back to if or go back to then. So it makes sure the transition is done right. And from else if you can go back to else if, or go back to, or just go to end and else and then end this. So you're able to do something like this and have an if else statement even within this set, and more intuitively tries to nudge you in the right direction, and you can have your select statements. So you see here we're trying to update the weapon, and depending on this, when we select this, we get the right stuff. Uh, And if we run this, everything passes. We have about probably over 2,000 tests now, and they all pass. So if you check the insert statement also, and maybe one thing I should show is how to work with it. So typically, when you're working with declaring the struct, there are many ways. So you can create a table, and this is space shape table, for example. You have to specify this attribute called table, but it has to align with this. So if you try to name it something else, and let's say you're naming this something, I don't know. This should actually, my my editor might be slowing down a little bit. This is going to give you a compile time error and tell you that this name should align with this. So it should be the snake case version of this. So I'm actually able to automatically do that without you specifying this, but I'm doing this to make it explicit. Um, so my Rust analyzer is loading. But one thing is, even when you make this mistake, you're gonna get an instant feedback that this should be the snake case version of this. But if you're so sure that that's what you want, there is another attribute called, I believe, relax table name or relax table, and that does that for you. So if we go check some more complex stuff, so let's go to alien. So if you look at all this, you notice that we don't have to explicitly specify the database type as we do in some other places. So this is how you do it explicitly. So here, for example, we're saying that the type of this is a record, basically this current table, alien with explicit attributes. This is a string, this is an integer. Despite that, if you try to say this is a string, you're gonna get an error. My Rust analyzer is loading for some reason, and that's why we're not getting that. But if we run a check now, we're gonna get an error. As you can see, it says that this is not, like, they are incompatible types. But because this is an unsigned integer 8, we're actually able to infer that. So if we remove this, it's still gonna work. But when it's not able to infer that, and I can show an example of a situation where it's not able to infer that. So if we take this unsigned integer and we alias that, let's say we alias that to, I don't know, age. Let's do something like that. Let's use unsigned integer 8. And it would do age year. Now we're getting an error. I actually need to improve the span for that. It should show that in line here, but still we get an error. Just it's showing at the top level. So I need to fix that. It should show that this should be in line. But a way to fix that is to then use the type attribute. So we can say, yeah, we can say type would be an integer. I might have to check this. Actually, I'm not working on my master branch. So I believe this, okay, yeah, so it was my ID that was Rust analyzers that was messing up. So that's the way you do it. You specify that explicitly, or just do that. So it's able to infer that, and when it's not able to infer it, it tells you to do it explicitly. And we see we can have a simple Surreal ID, which will be a unit, and we have the same for others. And this is how you link. This is like a one-to-one relationship. It links to the current table. And this is, we also have this type wrapper called link one for linking to one other tables. Then we also have link many for one-to-many relationship. Then we have a relate type for a relate struct, that basically you can think of it in when you're dealing with Postgres, it's more like a many-to-many relationship. So this is actually a read-only field, right? It's just more, and that's why we do skip serializing. Yeah, because you don't want to serialize this field because these are generated by your queries and lives on this alien visits planet struct. So you can actually even remove that if you're having just a simple definition. You can just do that and it's still gonna work. So we're saying that for this, these are for planets, alien visiting planets. So when you write your query, you can say you want aliens that have visited, let's say, specific planet, Jupiter or Mars, right? And you can get this deserialization. So the nice thing about these wrapper types, link one, link many, I should have some of their usages here. If I go back to these, they are called, I believe, I might have some of them here. Basically, they give you some helpers that you can use to do some stuff automatically. Let's see, maybe we have an example here. This has some helpers, so you can do find where you can put a condition into that. Okay, I'm gonna search load many. Okay, that's slowing down my computer a little bit, probably because I'm streaming. Do we have example of the usage? Yeah. So basically what those allow you to do is when you, in the case of alien, for example, when you deserialize into that, let's see if we can create a quick example here. Let's say alien, this is of type alien. With that, you get all these fields. So name is string, but when you get, for example, spaceship or you get any other relational field, you have some methods that allow you to do a bunch of, let's see. So for example, you can get the keys. So when you get the keys, it gives you the IDs. And because some of the IDs are can be nullable, so this returns the keys, basically the IDs of the foreign table. Then you can use key truthy. Keys truthy filters out the nulls, the null IDs, and I believe key checked returns only the keys that exist if there is a foreign link. And then you can also get the values. So values actually returns. So you can either by default, the IDs are loaded, but you can use the loaders to say you want to load the entire data for this foreign struct. And in that case, you have values. So values returns all the values, including the ones that are null IDs, that the reference don't exist anymore. Then values truthy filters out the nulls, and you can even count those. So you have all this bunch of helpers on these links or references or relations that help you, that like give you some convenience for working with the struct, right? So that's how that would work. But typically when you want to use that, I'm just trying to see some places where I've used that. One could be, let's see, a crate. So a crate is how you inserts. I think I might have used that somewhere here. So if you look at an insert statement, you can insert a singular struct. And one thing that I've done that I see that I've unlocked a lot of things is that I don't try to directly return this. So this actually returns the query builder. If we take that out first, let's say we remove this. This returns an insert statement. Only when you do like get one, it's gonna return the spaceship. And when we get that, for example, we're able to do, let me see, there are other methods that are available on this. So we can return one and we can load. So let's say there is a foreign field. We can say we want to load every relation on this. So when we get this data, we're not going to get just the IDs. We're going to get a full field. We can also say we just want to load the one-to-one relationships, or want to load the one-to-many relationships, or the self relationships. So it has a bunch of methods that enable you to do a bunch of stuff. Or you can say you want to load just these fields. So this allows you to specify a vector of the fields you want to load. So you can say I want to load books and planets, and it's going to load just those. Um, so you have all these other convenient functions that you can use on this. So you can just have an insert statement and it does that. And you can also, let's see more examples. You can insert multiple stuff. So here we're saying we want to return just name, right? So we can use this return one projections and we specify the type and we select the field that we want to return, which we get from this. And you notice that the way you actually get a field name is that you specify the struct and use the schema method. And here it gives you so here we can get created at also. The nice thing about this is we can do a bunch of nice things, which I will also show briefly. I want to keep this as quickly as possible. So with name, you have a bunch of helper methods for assigning. So for example, for equal to, you can do an assignment and you have all these, oh, my ID. Basically you have, let's see if I push that forward, if that's gonna help. You have all these helper methods. Okay, that's not helping. Basically, you have things like greater than, so you can have all these query methods. You can do GT, you can do less than, and if you're having a graph, you're dealing with geospatial data, for example, you can use things like inside and intersect. You have a bunch of methods. Here you can see, you see, I'm trying to show how you can insert multiple values. So you see that when you want to specify your link many, there are other methods you can use. So for example, you can say ally is supposed to be null originally, and here you can reference a table. So we're referencing an ID of a foreign table, and we're doing the same thing here for multiple. The nice thing here is you see we're saying we want to load just weapon. So it's going to load the values for weapon actually. And we're saying we want to get just one value. So get one, if it returns multiple stuff, it's going to throw a runtime error. But I believe when you're using return one, it's just going to return that as there shouldn't be a runtime error. It's just going to return that as a vector, I believe. So that's the nuance difference. Um, so yeah, we can return just specific fields. So yeah, we return just these three: age, name, and alien, spaceship, blah blah blah, and we deserialize into this. So that's one nice thing about that. Let's see where we're inserting multiple. We're loading. So this is linked many. Spaceship is the only linked many, I believe, on this. You notice that when we go there, we are able to get the values for that, right? We get the values as 3 here. I just want to show. I didn't realize there are a bunch of there are this many tests. Okay, I'll try to go down as quickly as possible. So anyway, inserting basically you just need to pass in a vector of struct into it, and that's how you insert into a table. It's pretty much that. Yes, so for the migration, before the migration, I can show you what I meant by the setter. So when you're setting something, I've shown a brief example earlier. You notice that age is supposed to be an integer, right? If you try to put in a string, it's not gonna work. Even if it's a number, it's not gonna work. You have to put in an integer, but you can also pass in a string, a field rather, and a parameter. And in this case, you're going to notice that we have organization. Let's see the definition of organization. For organization, we've got this time, and you see the time is actually an embedded object, which is another thing I haven't mentioned. So you can have the current tables, and you can also have embedded objects. In this case, it's just nested into this field, and that has a field called connected. You notice that we can traverse that. So the way you traverse when you want to go to a foreign table is you call a function, you invoke that. So you don't just call time as time, you actually invoke that, and then you can access this. Then you notice that despite this being a foreign field, right, in the embedded object, we also cannot put in just a number. It's expecting a date time. We also cannot put in a string because it's expecting a date time. And you can even go more complex. You can go more complex with this. Let's say you have a user field, which is actually, it links to a separate table. There's a relation between the two. Here you can say you want all users, so you use this empty alias. You can write it in full and say empty. Or you can say you want just the first user by doing something like this. And this would, okay, I should close that. This gives you the first user. And you can even have a where clause in this part, and it's still gonna work. So this is gonna give us, it's zero-based index. So this is gonna give us the fourth. And you notice that if we try to put in a number here, it's gonna catch that because it's expecting a string, right? So you can have very complex query. I believe I've got another example for that. So this is an example. So you can use also this with path stuff. And here, for example, we're saying we want index 2, and this links to best friend, and we can get best friend over best friend and get a course title taken by that best friend, and this generates this. And as you can see, it maps. It's very easy for you to reason how the raw query would look like, right? And you can also have condition between that. So for example, here we have a where clause. So you can get students that their ages are greater than 18. It's also easy to map that if you look at this query, or you can just get or. So you can write very complex query. And you have some convenient functions, which I showed earlier for every struct. For example, with this, we can find by ID, just specify the ID. And you can also use a where clause. So you can say find where name is equal this. So you have some other convenient function. You have count, count where. So count where the strengths are greater than 500, and a bunch of other ones. I think lastly, I can quickly go into um, see. I can go into the. I can show you what's if I query block. So with query block, and I'll show the migration after this. You can have something called object partial or object. So when you want to set something, you can use this object partial. Object partial allows you to set a few fields, not all. And what you're going to notice is that if we take this now, we have to pass in a number. If we pass in a string, also we should get an error. But you notice that we are also able to pass in a block and have a complex query within this, which reads almost exactly how the raw query would look like. So here we're saying that we want to select value, basically strength from weapon. We get that, we can sum that up, and we can find the length of that, and we can even have much more complex mathematical expression with a C, then wrap that with a seal function, and it does all those things, the parameterization, the sanitization for you. And when you look at the raw query, it looks almost like what the query turbo, I call this query turbo, looks like. So with this, you can write the raw query, like I showed earlier, and will also be type checked at compile time, or you can use this query turbo syntax. And this also works. And as you can see, when we sum all the strength here, we do that, we get the right, when you do the evaluation, you realize that we actually get the right result here. So within this, you can have an if-else statement, you can have a for loop, you can use a map, different array functions, map functions, graph functions. There are a bunch of functions that SurrealDB supports. So this allows you to do very complex queries. And you notice if we try to put in, let's say we mistype this, we should also get an error because that field doesn't exist, right? If we were to use objects, just mere object, this says that we actually have to put in all the, so it's expecting two fields, but we've only specified one, right? So you have to use everything when you're using object, but objects partial allows you to specify just some of those rather than all of it. And yeah, there are a bunch of things, but I think what I can show is the migration, um, and I can show that from the README directly, or we also have relate queries and a bunch of stuff, but I think I should just show this quickly so we can do Q&A. So you can embed your queries, and yeah, we have a migration test. So it supports different kind of migration, and we have very comprehensive tests for that. We'll try to go through that quickly in the README just for the sake of time. Please stop me if you have any question or if you want to ask any question. Okay, we have a bunch of stuff. I mentioned about this query turbo and transaction, and we have the raw queries. So we also have the migration. So how you work with migration is basically you can have a bunch of your database definitions. And if I go back here again, actually, I'll show you quick stuff now that I'm here. I can show a quick thing. You can also use, I showed object partial earlier. You can use this method on a struct called partial builder. And with that, you can specify, like, you can select certain fields that you want, and it's going to skip others. It's not going to serialize other fields that you've skipped. And as you can see for weapon, for example, passing a rocket, and again, everything is checked. You cannot put in a string here. So if you skip a field here, it's not going to serialize that. And the idea of this is meant to be used in an update statement typically, where you might want to update some field or do some margin. And a bunch of other stuff. Yeah. Yeah. And I forgot to also mention that in update query, you can do a patch, like a JSON patch. You can patch a specific field, and there are different patch method or functions. So yeah, we are adding this to this specific field. You can do very complex queries with this. But anyway, without digressing too much, we can have, I believe, um, attributes. So in this planet visit stuff, I think I have some more complex. It also, of course, you can use generics. This supports having generics also. Um, I'm looking for more complex. So here you can see that when you're defining a struct, this is more complex. Most of the time, a lot of these things are going to be generated for you. You can actually have the table name. You can say that you want the table to be dropped. You want it to be flexible. And this is used, I believe, for materialized view. Oh, no, actually, yeah. If you want to do the initial population of the table from this, then you can specify the permission. Then you notice that in your permission, you can actually link to a separate method. The benefit of this is that you can share this across structs, right? So we have these two permissions, and you notice that we can actually specify one, or we can do something like this. That works. We can do this. This also works. And we can even specify multiple connections. You can do this. This should also work. And another benefit of that is that you can pass in a, so here you see this is a permission, right? You are able to pass in the entire expression inline. So you can assign this, you can make this a function and call this, or use this inline. This also takes an inline expression, but you can take that as a function. And if the function doesn't take any arguments, you can just leave that bare like this. So this will also work, or you can just do this. And the benefit of that is that you can have a function that takes an argument and you can just specify different parameters. So this allows for more or better reusability. So what I'm trying to drive at is that when you do all this table definition, the way it works is that you're going to specify this table resources trait for that specific table. So this allows you to do extra definitions. You can have an event definition. Also, you can specify your indexes for the table, and you do that for different tables. This is an edge, and you also specify DB resources. So this is basically aggregation of all the resources from your code base. And this can be in a different crate if you're working with a workspace. So basically here we've got eats. So animal eats crop. We've got an animal with these definitions, right? So here we can use these create table resources and specify all the structs with their own definitions. So it automatically does that for you. And then you can have different top level definitions like analyzers, functions, parameters, scopes, and tokens and users that can be used across your query. And when you do that, you can use this migration run function, and it does everything for you. So the way it works is that you first initialize, and after initializing, the benefit of initializing first is that for the subsequent query, you don't have to specify if it's unidirectional or bidirectional. It's able to automatically detect that. So when you initialize, it generates your stuff originally. Then after you do that, subsequently you can generate new. So when you change something, let's say you add a new field, you can run this code gen, and it's going to generate that for you. Then for up, you can do cargo run up. This is to latest, alias latest. You can also write latest in full. and latest is the default, then you can say you want to go the delta just 5 levels up, or you want to go up to this point in time, and that is also going to work. Same works for the down migration, and you can also reset, start all over, or you can prune. Let's say you've generated a bunch of new migrations, but you want to prune that. Basically, you want to remove that and go to the latest ones that have been applied. You can call the prune function, and we have lists with different status. Like if you want the pending, the one you've not applied, or just the ones you've applied, you get all that. And by default, you don't have to specify an extra argument, but you can also specify like the database, the namespace, the username, and the password. And in addition to that, when you generate a migration, you can embed it into your binary using this embed migration macro. And you specify if it's one way, basically it's unidirection, or two way. And yeah, that's mostly it. I could show lastly an example of some automatically generated migration in the test.
Okay,
Yeah, I believe.
I just
Yeah.
want to let you know that we only have 15 minutes left in our.
Oh, all right. I believe that's mainly it. These are just examples of generated migration. But yeah, I think that would do it for me. I'm happy to take any questions.
How long did this take to build? It seems like a lot of work. And it looks like when I looked at the repo earlier, it looked like you were the one who worked on this.
Yeah, I've been working on this, I believe, for about 20 months now, so about 2 years.
Oh wow.
Of course, I've done a large part of it since last year, but I've been doing. I think about all the little details and how I can improve them and things like that. Especially because I'm expanding support to other databases, and I also think how this will be consistent with all the other ones. But I've been working on this for about 2 years now, and we're close to being done with this.
How many have you done much performance benchmarking at all, or have you compared against other frameworks?
Pardon, I missed that a little bit.
Have you done any like performance benchmarking? Have you compared against other frameworks or libraries in the ecosystem?
I've not done any. Do you mean performance benchmark?
Yeah, like like how much overhead is there to this to using this ORM versus like other solutions? I don't know.
So because most of these things are done at compile time, and one thing also, one of my philosophies is that there shouldn't be there should be magic. It should feel magical, but there shouldn't be magic. Like what you see is what you should get. And so much of the performance bottleneck lies with the underlying engine itself. In this case, we're using Surreal-DB engine. So I don't believe there should be the ORM itself should make much, or the query builder checker should make much difference in terms of it just basically generates the query and make sure they're like valid for you. That's what it mostly does. But in terms of the underlying engine, there shouldn't be much difference in that.
All right, I think we got a question here.
Hi, yeah, thanks for the presentation. Looks like an awesome library.
Thank you.
Looks like kind of all the stuff we love about Rust, right? Like the strong types and the code that kind of like writes itself and like guides you down the right path. I'm curious. There seems to be a lot of macros and like procedural macros and stuff. I'm curious, if you ever struggle with like slow compile times when using this library, and how you might mitigate those. And then I'm also just kind of curious under the hood about like anything you want to share about how those proc macros work, like what kinds of dependencies you're using, what kinds of cool crates in the proc macro space are you using for that?
Oh, great question. So to the first question, the overhead. Of course, when you're writing macros, there would be some overhead there, but there are not things that I've not run into any major issue. Of course, I'm using the M1 maxed out spec, so maybe that's a factor. But I haven't had any major issue with the prop macro in terms of the performance. And yeah, to your second question, I've used libraries like Syn and NumParser, and I believe Darling. Those are the three major crates I've used, and mostly there were a bunch of stuff that I used macro rules for. Like for the transaction macro, I actually had uh, this uh, macros I wrote, which was quite complex. But I eventually moved that to procedural, writing just the procedural macros, and that has been very, very helpful because I can much more specifically tell it what I wanted to do. Um, so I found that I only use macros for very basic, repetitive kind of stuff. So I'm using that for, I believe, object and object partial and simpler stuff like that. But when I want to do much more complex, expressive stuff, I've um, gone towards more attributes or just other procedural macros, and that has been helpful. I'm looking to create a course on procedural macros if people would be interested. That's something I'm looking into. Does that answer your question?
Yeah, thank you.
I have another question.
Okay.
First of all, thank you for the email and presentation.
Thank you.
Before I go to the question, I want to note that I really like that the query builder looks like just plain SQL. I can really relate to it when you work with some query builder and then you like know what the SQL query you want should look like, and then you find the query builder to make it look like that. So I can really appreciate that with that straightforward. But my question is about migrations, and you mentioned the bidirectional migrations. What is the use case for bidirectional migrations? Because usually when we, like from my experience, when we work with migrating database and changing something, we just go from the current version to the newer version, and if something goes wrong, you just roll back. So I'm curious about the cases when you want to migrate back to the previous schema.
Yeah. Oh, thanks. Thanks for the compliment. And to your question, if I get it right, you asked what are the use cases for the bidirectional migration?
Yeah,
Is
if
that
you
correct?
can share some experience, I would appreciate it because
So in my experience, I think mostly, of course, that is for rolling back. So if you pushed a bad migration to production, you can then roll back to the previous one. But in my experience, that is rarely done. And in my opinion, I wouldn't also recommend that because oftentimes people add some extra queries when they're writing the migration, and it's it can often be difficult to guarantee that you're reverting. Rather than that, I would just create a new migration that does the um, revert reversal of that. So personally, I tend to um, use the unidirectional, but I'm trying to also give people the option, like you can eat your cake and have it. And that, in my opinion, is more relevant, at least when you're using things like SQL Alchemy during development. So you run a migration by mistake, and that is because mostly people use an external database connection. So you have a Docker or a Postgres running locally, and you've applied the migration. Now you want to revert that because you want to create something new and you don't want to generate a bunch of migration. In my experience, that's when I've seen the revert migration uh, useful, but also it leads to a bunch of, at least when I've used other ORMs, you reverse the migration, then realize that you encountered some issues, you delete some stuff, and everything is broken. So especially in this context where we don't need a live database connection, we do everything embedded, it becomes even a lot less necessary. But again, I'm trying to give people the option if they desire to use that. So it goes to the philosophy also of being able to eat your cake and have it. If you prefer for a specific scenario, if you prefer a query builder like this, you have the option of a well-supported query builder that looks clear. It doesn't even look like cross. This could be a Python or even a TypeScript code. It doesn't have specific Rust construct. If you prefer to write raw queries, it shouldn't leave you. You should check your raw query at compile time. If you want to use some LPower method, it should support that. You want to run your migration, it should also support you. So that's the philosophy. Is should be able to. You shouldn't have to make the trade-off all or nothing. It should be a situation. Oh, I'm writing this query. I think this would be nice. It will give me more flexibility. Let's say I'm trying to have a bunch of conditions. Let's say I'm working with some complex, maybe with GraphQL, and I want to say if this is, I want to have, let's say, select this, but if this is this, then add this additional condition to it. Then maybe query builder could be good, or you could even have a raw query says this supports if-else statement and for loop. Does that answer your question?
Yes, thank you so much.
Oh, you're welcome. Absolutely.
I just was wondering, are you using this project in any other like current projects that you're working on? Like, is this a 1.0 or what is like the current state of this, do you feel?
So that's a good question. Actually, this project started as I was working with TypeScript, but I wasn't quite happy with it. So I built some libraries to do some infrastructure work, basically a one command deploy everything, your object storage and everything. And then I had to switch to Rust because I didn't like the concession I had to make, the trade-off I had to make with TypeScript. And when I switched to Rust, I realized that I tried, I believe, 10 different, like I mentioned, RBTs, SQLX, and CORM, and a bunch of other stuff. Uh, but like the issues I've mentioned earlier, I wasn't quite happy with them, even try to make them work. And that was why I decided to build this so that I can use this in my project and share this with the community. And that was what birthed this project. So this was meant to be a means to an end. So have something that would allow me to be very productive. If I'm working alone on a project, I want to be able to build that project fast, but without having to spend time fixing bugs. Like I just want to write the query and I know that this query is going to work. It's going to give me the desired result without having to, oh, did I write this right? Did I mistype this? I want something that would work and make me be very efficient. Whether I'm working solo or I'm working with a lot of people. So that was what led to this. So right now, like I said, I have a PR currently open. I have that is mainly the last one and maybe a bunch of cleanup. I'm planning to upgrade this to there's sorry 2.0 alpha, so I'll update that. Those are the two things left for this to be ready for 1.0 alpha before the release. And the plan is that once this is ready, I'll start already working to support Postgres, SQL, MySQL, even MongoDB and Cassandra. And I know it's feasible from building this. I already know how these things are gonna map with each other. And I think things like Postgres would be significantly easier to implement because you don't have support for a lot more complex queries that SurrealDB does, like having to traverse the entire graph to access them. So those are, in my opinion, would be a lot more straightforward than this. And that was another reason I decided to start with graph, start with something more complex that can allow me think about bigger ramifications of the solution. Does that answer your question?
Yeah, no, that's awesome. Yeah, if you want to do a tutorial on procedural macros, yeah, you'd be welcome to come back and do another talk on that. I don't think we've done a talk on procedural macros here yet. No one's actually done a tutorial on that. So if there's interest there, then yeah.
Absolutely, I'll be happy to do that. I also have this crate called, I believe, Twost. If you're interested, like this basically does compile time check of
Still see the ID.
till. Oh, you still seen? Okay, I can just share it in the. I can share this in the chats, or I can just switch. So I have this, and I can share the first one also. So what this allows you to do is check your Tailwind CSS class at compile time. So you mistype the type. If you mistype one of those classes, it checks them, and it's actually quite strict on checking those. Yeah, I'll totally be happy to also do at least some tutorials on the procedural macros and make a book in this meetup, and also make some elaborate tutorial and maybe a book on that, on basically pretty much every kind of procedural macros.
Oh wow. And you built this yourself as well.
Pardon?
So you built this yourself as well.
Yeah, I wrote that also to check Tailwind classes at compile time, and I have a bunch of stuff also planned for that.
Is this published on like Crate.io?
You mean Twost?
Yeah, plus.
Yeah, it is. It is.
Oh, okay.
Yeah. Yeah. So I'm planning to support things like arrays of classes and like just a bunch of other stuff. But this is currently published and it's usable today.
All right.
Not
Do we
just
have any
usable
other
by a million
Oh,
people.
Sorry, I missed that.
Now I was saying it's not just usable, it has 193 million downloads.
Yeah. Oh, you mean the download on Crate.io?
I don't know. I just the on the I call it the README as a picture.
Yes. Hopefully someday.
Okay.
Yeah. Are there any other questions, concerns, suggestions, recommendations? I'm happy to. Yeah. And actually, I've been streaming some of this on my channel. So during the implementation of this, I've been streaming them. The channel, I believe, is called Code Breeder. So I do the implementation live when I can.
Which service is that on? Is that on like YouTube or is that on
It's YouTube. YouTube.
YouTube? Okay.
It's
You
called
can
Code
also send
Breeder.
us a link to that if you want. Might be interesting to some folks.
Oh yeah, so it's called, I believe, Code Breeder. If you search stuff on procedural macros, you'll probably find some things there. Yeah, so well yeah, this is what I've been mostly working on, and I have some other stuff that are private. I also have a library for doing OAuth stuff. If you've used like Passport and JavaScript or TypeScript, I have something similar in Rust and some other libraries that I could open source. Like I have this library for also picking. I think I pick something like this. So the idea of that is that you have this, let's say, original struct with generics and lifetime. You want to specify this new struct, and but you want just name and age. Now you have this, and you can even have an additional derived macro on that. So let's say we've got new person with name and age, and you can see here we have new person with name and age with the generic. So if you happen to change that definition here, or let's say you're trying to select something that doesn't exist. Let's say you're trying to select I don't know, let's just say something. It's complaints. So that's the benefit of that. So I have a bunch of little utility functions that I've used both in these libraries and other places that I'm looking to put together to like basically do some static assertions. Oh yeah, I've been working on this fully now for about a year. But now as I'm nearing the completion, I probably would be more open to I think I am quite happy with where it is now. Once this 1.0 is ready, I can work on other projects. I'll also be open to opportunities to roles. If you have some roles opening at your company, let me know.
Sorry, opportunities to. I didn't quite I didn't quite understand what you said.
I meant to say that I've been working on this full time, but now that this has basically neared completion, I would also be open to like roles, engineering roles, because I've been working on this fully for at least about a year. I wanted to focus on this to finish up significant chunk of it.
Okay. Unless there are any other last minute questions, we're 5 minutes over time right now. So, yeah, thank you very much for presenting. This was a very interesting project. Very
Thank you.
fantastic presentation.
Thank you.
Thank you.
And we'll be glad to have you back if you ever want to talk again. And yeah, maybe I'll check out your channel as well.
Absolutely. Thanks for having me. I appreciate it. It's been nice chatting.
All right. So yeah, I don't really have anything else to say. Next month, I'm going to be doing a talk about the various cell types in Rust. That's the current plan anyway. It should be kind of short and sweet. And yeah, otherwise, that's pretty much it. So thank you all for coming to the meetup. And yeah, that's pretty much it.
Thank
All right,
you.
thanks. Bye.
But
Thank you.
oh, thanks, Steven. I appreciate it. Have a wonderful night, everyone.